Alright, so this is on page 164, okay? So these are more applicational questions, okay? So this cover part we talk about the rates, okay? Rates, because a rate is a ratio between measurement with different units, okay? So blah blah. Common example is the speed of a car, okay? So the risk problem, okay? Risk problem, say mile per hour, okay? These kind of units, okay? It's not a single unit, right? It's not from inch to feet. It's not an inch or feet, or it's not a single unit. It's what? We call it, this is a combination unit or complex unit, because this unit only has 2 units in it, okay? See, this kind of units we call complex units, okay? And the risk question will mostly talk about this type of units, okay? Mile per hour, mile per gallon, and something like that. So we are going to convert between what? This type of unit to another complex units, okay? So this example, okay, I'm going to show you one example and I'm going to show you another practice question, okay? So example, I'm going to ask a volunteer to read everything and we'll fill out these blank areas and we'll solve the problem. Whose turn? Leila?
Suppose a car is traveling 35 miles per hour. How many feet per minute is this? Notice we start with 35 miles per hour written as a fraction with 35 miles on top and 1 hour on the bottom. Fill in the identity ratios to convert feet per minute.
Yes.
35 miles over 1 hour times feet over miles times hour over minutes equals feet per minute.
All right, thanks so much, okay? All right. Note the order of identity ratio doesn't matter. Time could be converted first. Okay, so let's see why they're talking about this. Our aim is trying to convert from what? What is the unwanted unit, everyone? Mile per what? Hour. Okay. What is a desired unit? Feet per minute. Okay. So now we're trying to convert 35 mile per hour to what? To feet per minute. Okay, I'm going to write it here like this. Okay, feet per minute. Okay, this way it will look more clearly. Okay, from mile per hour to feet per minute. Okay, how to convert? See, for the length, okay, the given unit is what? Miles. Okay, miles. We want to convert from miles to what? To feet, right? So that means we will convert from mile to feet, okay, for length. And then for the time, the given unit is what? Hour. We need to convert from hours to what? In minutes, okay? So that means we have to do what? 2 conversions, okay? One conversion is for what? The length, from mile to feet. The other conversion is from what? For time, from hour to what? 2 minutes. Guys, do you see that? Okay, we have to do 2 times conversions, okay? Now let's do from mile to feet first, then time. Or we can convert from, for what? Convert from hour to minute, convert time first, then convert what? The length. It doesn't matter, so that's why it says the order of identity ratio doesn't matter, okay? Either way we do, okay? So we will convert from mile to feet. How? Unwanted is mile, so we put mile on the bottom, right? What is the desired unit? Feet. So we put feet on the top, okay? So this way, mile can be cancelled. Now, what is the relationship between mile and the feet? Mile, feet. Mile and feet, they are within the English system, right? Every 1 mile equals 5280 feet, right? So 1 mile, 5280 feet. Am I right? If I do something wrong, let me know. Correct me, because sometimes, I may make mistake, okay? All right, so now this way we don't have mile as anymore. Eventually we'll have a feet left. Okay, then we'll convert in time from hour to minutes. What is the relation between hour and minutes? Every 1 hour equals how many minutes? 60, okay? And because this unwanted units is on the bottom, in order to cancel out this unwanted units, we have to put the hour on the top this time, okay? So this way, hour cancel out, okay? And we know every 1 hour equals what? 60 minutes. Now you see the desired units are what? Feet per what? Feet per minute, right? Alright, now to fill out this number, okay, what do? We use 35 times 5280 times 1 divided by what? 60, right? So use your calculator and tell me your answer, please. What do you get?
3,080. 3,080.
And 80. 3,080 feet per minute. Everybody get the same answer? Everyone? Okay. So this is this example. We'll see we're converting between one complex unit to the other complex units. Okay. Now, just now I assign you guys to try question 1 and 2. Yes, you can try them. Okay. Now I'm going to do the third one. We're going to do the third one together. Okay. Third one need more conversions, okay? Yeah, more conversions. All right. So, Kathleen, can you read question 3 for us?
You buy a pump that is rated at 2,500 gallons per hour, GPA for GPH. How fast can it pump in liters per minute?
All right, thanks. We're going to convert from 2,500, what is this? Gallon per what? Hour, right? This is a unwanted units. What is the unit we're desired? Liter per minute. Okay, so it's a liter per minute. Okay, liter per minute. I use capital L. Okay, yeah, liter per minute. So that means we can see that, okay, from gallon to liter, this is for what? Volume, right? Is that for volume, right? Volume conversion. And from hours to minute, that's conversion in time, right? So we're going to convert from gallon to liter and also from hour to minute. From hour to minutes, we did it just now, right? So every 1 hour, 60 minutes, we can do that. Okay, one-time conversion done. Now from gallon to liter, do we have any direct connection from gallon to liter? Oh, from gallon is in the English system. Liter is in the what? Metric system, right? So okay. What we see is between the two systems, we know quart to liter, right? We know quart to liter. And then what we need is from gallon to liter. So we know quart to liter, right? This is part of conversion. Do we know the direct connection between conversion between a gallon to quart? Do we? See here, every gallon equals what? 4 quarts. And then use what? Quart to what? Liter, right? So we know that for this conversion, we're going to do from gallon to quarts, right? And then from quart to what? Quart to liter, okay? Quart to liter. Okay, so this way, gallon is gone, quart is gone, we'll have liter left. Okay, so guys, do you still remember the relation? Every 1 gallon equals how many quarts? 4 quarts, right? And every 1 quart equals how many liter? I couldn't remember the number. Can you tell me what is 1 quart equals how much liter? 0.9 something, right? 0.9.
9464.
9464, yes. All right, then when we convert from hour to minutes, right? Hour, we put it on the top, and then minute, we put it on the bottom. This way, hour can be gone. We know it's 1 hour per, 60 minutes. Now we're very happy because now we're having liter per minute, right? So this is liter per minute. Then you have to do all of these calculations, okay? Cassidy, what do you get? What's your answer?
157.73.
157.57?
No, 73.
73? Liter per minute? You get the same answer, everybody? Okay. Alright, so this is the answer. Okay, this is the answer. Alright, so this is rates questions. What do you feel? Well, you have to set up the, do the conversions again and again, okay? Yeah. Alright, so the question 1 and 2, I want you to try them by yourself, okay? By yourself. Alright, page 165. Applications with rates. Okay, so we're going to talk about this type of questions as well, okay? So I'm going to ask a volunteer to read, okay, everything above question 1. Okay, everything above question 1. Whose turn?
We will solve application problems by applying a rate to a given value to solve for a value with the desired units. The speed limit on some highways is 65 miles per hour. Think about what 2 conversion ratios you can make from this information. 65 miles over 1 hour or 1 hour over 65 miles. Now let's see how to use this. It is 120 miles from Lafayette to Fort Wayne. If someone travels an average speed of 65 miles per hour, how long will the trip take? Note, the question asks how long, so we want the result in what unit of measure. Start with the given value, then apply the rate, fill in the identity ratio, and solve. 120 miles over 1 hour times hour over miles equals hours.
All right. Very good. All right, so this question talks about, the distance between these 2 cities are 120 miles. If someone travels an average speed of 65 miles per hour, okay, from the 65 miles per hour, we can get 2 conversions, identity ratios. Either 65 per hour or 1 hour per, per 65 miles, either way, okay? So this information gave us 2 identity ratios. And it asks us, how long will this trip take? So, what do you think about the units of measures for the results? Because it asks for how long, it's going to be what? What's the unit? Hours, right? Or time, okay? We say time in hours, okay? Because it asks for how long will the trip take, right? Now, how to solve the problem, okay? So, we're going to set up conversions and identity ratios like this, okay? 120 miles, this is the distance. The given unit is a distance by miles. Eventually, we want to convert it into what? How long? Into hours, right? What are the given information? 65 miles per hour. So there are 2 identity ratios we already know. We're going to use one of these to cancel out the miles and get the hour. Which identity ratio should we choose? Should we choose this one? Or should we choose this one? Because we want miles gone, right? Unwanted. So we're gonna put in miles on the bottom. We want hours, which is desired, we put hours on top. So which identity ratio should we choose from these two, among these two? Which one? Second one, right? Second one. So 1 hour, 65 miles, right? Now the miles could cancel. We have hours left. Okay, so 120 divided by 65, so it's going to be 1.8 something or 9 something. 1.8 what? 1.84 hours. Okay, so with this speed, okay, and then to drive 120 miles, it will take us 1 hour, 1.84 hours. You guys, this example? Alright, so can you try question 1? I'll give you 2 minutes to think about and try it. Same distance from Lafayette to Fort Wayne, 120 miles. This time, the speed is 55 miles per hour. How long will your trip be? It's exactly the same question as this, okay? Let me ask some of you guys, tell me how to do it, okay? Any suggestions about question 1? Damon? Yeah, how to do it? Tell me, how to do it?
120 divided by 55.
Divided by 55, right? So yes, it's right. So if we write it down, it's going to be what? This time is 55 miles 1 hour, right? So 55. So this way, we should have 120 divided by 55. So what do you have? 2 point something, right?
2.19.
2.19 hours. 2.19 hours, right? Yeah. Yep.
Do you want us to round it if it needs to be or no?
Well, it doesn't say you have to run it to how many digits. You can't get a 2.2 here, I would say, or 1.8. Okay, so it doesn't say. So 2 digits is more accurate than 1 digits. So if you put 2 digits, that's okay. But some of you guys prefer to just run it to tenth, run it to the 10th, just keep 1 digit after the decimal points. Okay, that's also fine. Okay, yeah, 2.19. Oh.
I rounded the last one.
Okay, 2.18 hours, right? I'll write down whatever you tell me. What do you get? 2.18?
Yeah.
Yeah, okay. And also we can see that for the same distance, if you drive faster, it takes what? Less time. If you drive slower, it takes what? More time. That makes sense, right? So you can self-check by yourself, okay? All right, so this is question 1, okay? Question 3, I want you to try this question later by yourself. And then let's do one more question, okay? Question 2 together, okay? I'm going to ask a volunteer to read the question for us. Cassidy?
From experience, the school's Ford Fusion Hybrid can get 47 miles per gallon. How much fuel will it take to drive from Lafayette to Fort Wayne? Use current gas prices to estimate the fuel cost for this trip.
All right, good. All right, so this car, okay, yeah, Ford, okay, can get 47 miles per gallon. So we always write it down, okay? It doesn't hurt, we write down the given units, okay? So mile per gallon, this is a given or unrounded units, okay? It asks us what? How much fuel will it takes? Use a current gas price. So what is a current gas price here in Valpo or nearby? Do you remember? Every 1 gallon, how much? 2.5 or 2.8? I don't,
2.47.
2.47?
Yeah,
Oh.
Family Express.
Family Express, okay, so I use $2.47, okay. So 1 gallon, we will take around it, it will cost $2.47 per gallon. Well, also, you can write 1 gallon per $2.47. We'll see, okay, because all of this information give us two identity ratios, so we'll see which one we use. So far, I'm going to put down this to tell us, oh, a gallon will cost $2.47, okay. All right, now, what is the given units then? Given units is what? Mile per gallon, right? Mile per gallon. So we want to know the price, dollars, right? But, in order to know how much it will cost, we need to know from Lafayette to Fort Wayne, right? From Lafayette to Fort Wayne. Oh, still 120 miles, right? Okay, so how many gallons of the gas it will cost? Then we compute what? The price, right? That makes sense, right? If you know how many gallons it will cost you, and then we just multiply by 2.47, that will give us the total cost, right? So now our aim is trying to figure out from Fort Wayne, okay, from Fort Wayne to Lafayette, how many gallons it's gonna cost us. So how, everyone? What is the distance? See, this I said it doesn't hurt. Well, it hurts. Okay. So how many gallons it will cost us? What is the distance from Lafayette to Fort Wayne? 120 miles. To drive this many of the miles, okay, we know that this Ford can get a 47 mile per gallon. Okay, the 47 mile per gallon can give us two identity ratios. 47 mile per gallon or 1 gallon divided by what? 47 miles. So which identity ratio do you want to use? We don't want miles anymore. We want to know how many gallons we can get, right, to drive this 120 miles. So this is every 1 gallon, 47 miles. You agree with me? Now, if this is the case, miles gone, so we can get how many gallons it will cost, right? Yeah, it will cost us. And then also we know that every 1 gallon, it will cost $2.47. So, gallon canceled out. We only have a dollar sign left. Okay, so it is 120 times 1 times by 2.47 divided by what? 47 miles. Okay, so you can round your answer to the hundredth, round it to the cent. Stephanie, what do you get?
6.42.
$6.42, $6.42, okay, for this car to drive this long, well, drive this distance, $6.42. Everybody, same answer, 6.42 or no? No? What do you get?
6.30.
6.30? Probably just type in, okay, 6.30. Everybody agrees with 6.30?
No, I got 6.42.
See? Everybody? Alright, so let's use our calculator and double check. Okay. Where's the calculator then? Here. Alright. So 120 times by what? Times by 4.7, right? 2.47. Divided by what? 47. 6.31, right? I got a 6.31. Okay, so 6.31 right? Okay, so these type of questions you will have to practice as well, okay? All right, so let's turn to page 166. This is a last tiny bit of the materials we are going to cover. It's a temperature conversions. These formulas will also show on your formula sheet in your exam, okay? So we talk about Celsius and Fahrenheit, okay? Well, here in the United States, we're using Fahrenheit, but in most of the country who are using the metric system, they measure temperature by Celsius, okay? So these are the conversions between Celsius and Fahrenheit. There are two formulas we need to know. One formula is to convert from what? A given degree in Celsius to what? Fahrenheit, okay? If C is given, plug in the first formula, we get F, okay? All right, and then so F equals 9/5 times C plus 32. So what is 9/5 in decimal number? 9/5 in decimal number, what do we get? 1.8, yes, times by C plus 32. I'm asking you guys about the order of operations. We have multiplication, we have addition. Which operation should we do first? Multiplication. No parentheses in this formula, so do multiplication first, then add by 32. Okay. All right. If a question, Fahrenheit is given, we use this formula to get a Celsius, right? Now, in this formula, okay, we have a 9/5, okay, 9/5 times by the parenthesis, F minus 32. I'm asking you how to do the calculation. Do we do subtraction first or we do multiplication first? Multiplication. Pay attention, there is a parenthesis. So we do F minus 32 first. And then how do we do with this 5/9? Multiply this result by what? 5. And then divide by what? 9. Okay? So once we get this parenthesis, the result from parenthesis, multiply by 5 and divide by 9. Alright? Alright, so we have two quick questions. Let's look at both of them quickly. Okay, I'm going to ask a volunteer to read question 2. Okay, Evan, your turn.
You get sick while in Montreal and go to a clinic. The nurse says your temperature is 38 degrees Celsius. Should you be concerned?
Okay. Well, for most of us, we're more familiar with Fahrenheit, right? So 38 degrees in Celsius. That means we need to convert from C to F, right? So we know, oh, is this degree high or not, right? So from C to F, which formula should we choose? Which one? We know C. We are going to use the first formula, right? So F is going to equals 1.8 times by what? What is the given degree C? 38 plus 32. Order of operation, do that multiplication and then addition. Kristen, what do you get?
100.4.
100.4 degree in what? Fahrenheit, right? Fahrenheit. Okay, so or you just say 100.4. Okay, should we be concerned? Well, it's a low fever, right? So I would say that we should be concerned. Okay, so low fever, right? All right, question 3. Okay, I'm gonna ask. Andrew, can you read question 3 for us?
Converting people room temperature 72 degrees Fahrenheit to Celsius. Rounding near hundreds.
Okay, good. Now we're going to convert from Fahrenheit to Celsius. We know F. To get a C, which formula should we choose? Which one? We know F. The second one, right? So temperature C equals 9/5 times by parenthesis 72 minus what? 32. Which operation should we do first? Subtraction, right? Subtract, yeah, do subtraction, you get a number, then times by 5, and then divide by 9, okay? So, Lauren, I'm going to ask you. decimal.
22.2.
22.2 degree in what? Celsius. Agree with Lauren, everybody? Okay, so 22.2 degree in Celsius. What I know, I'm more familiar with this. This is a very comfortable temperature, okay? It's a good one, okay? All right, so that's it for section 13, okay?